All right, if you're a developer looking to absolutely supercharge your efficiency, you are in exactly the right place. Today, in this explainer, we're fundamentally shifting how we use the Gemini command line interface. We're literally going to turn it from a simple chat interface into a fully automated, dynamic, local development agent. It's a massive upgrade. So let's dive right into this masterclass on Gemini CLI custom commands. Here's our agenda for today. First, we'll look beyond basic CLI commands, then break down the anatomy of a custom command, dive into dynamic input with args, walk through an awesome case study on automated components, look at self-correction in live previews, and finally wrap up with activating your new workflow. Okay, part 1, beyond basic CLI commands. So you've probably used the out-of-the-box stuff, right? Built-in commands like /model, /settings, or maybe init. But the real power user capability, that lies in custom commands. When you define these yourself, they behave way less like simple prompts and much more like highly capable local apps. Imagine building a dedicated bug fixer command that just scans your workspace and fixes errors, or a multi-step Git tool. Today, we're focusing on creating a fully fledged component builder, and honestly, it's going to completely change how you approach creating new files. Moving right along to Section 2, the anatomy of a custom command. So we got to build this system layer by layer, starting with the infrastructure. The crucial first step is getting your directory structure exactly right. Make sure you have a .gemini folder right in your root directory. Inside of that, you'll create a subfolder called simply commands. This is where all the magic happens. You register a new command by creating a TOML file in there, and the elegance of this is just fantastic. Whatever you name your TOML file, say component.toml, that automatically becomes the actual / command in your CLI. So / component. Pretty slick, right? So what actually goes into that file? Inside your TOML file, you need 2 essential keys. First up is the description. This is just a short string for metadata. It's literally what you see in the CLI UI when you type the command, like create a new UI component and test file. The second key, though, is the prompt. This is a massive multi-line string containing the exact instructions for the model. Basically, it's the brain of your automated app. Which brings us to Section 3, dynamic input with args. Now, a static command is cool, but a dynamic one that adapts to your task, that's a real game changer. And this right here is the secret sauce, the args variable, enclosed in double curly braces. It automatically captures any user input you type right after the command name. So if you type / component and then add a circular avatar, that text is captured by the args variable. You inject this directly into your multi-line prompt, which allows Gemini to take your specific instructions and drive its whole logic flow. Let's see this in action. Section 4, Case Study on Automated Components. We're going to look at this mind-blowing real-world application from a NetNinja tutorial. It shows a single custom command that completely automates generating a Nuxt and Vue UI component. Just look at the sophistication here. Triggered by one prompt, it checks your Git status, handles contextual branching, runs a full test-driven development loop, builds the component, and then renders a live preview. This is a true power user setup. We're effectively turning one gigantic prompt into an automated developer colleague. And check this out. Notice how we use natural language to build safeguard railguards. Before Gemini writes even a single line of code, the prompt tells it to check the get status. Like the quote says, if there are uncommitted, unstaged, or untracked changes, abort the process and tell the user to stop. You're using plain English instead of writing complex bash scripts to protect your uncommitted work. It's incredibly smart. Now, assuming your working directory is clean, the prompt moves to contextual branching. It takes that args description you typed in, like that circular avatar, and uses it to derive a safe branch name. It enforces a strict naming convention, specifically component / slug, in lowercase kebab case. Then it just automatically runs the git command to create and switch to that new branch for you. No manual typing required. All right, Section 5, self-correction and live previews. This is where the CLI stops being a basic chatbot and really starts acting like a senior developer. The lifecycle is phenomenal. The prompt strictly instructs Gemini to write a suite of meaningful tests first, but it says don't run them yet. Then it builds the actual camel case component. Only then does it run the tests. And here is the absolute magic. The prompt tells the AI, if tests fail, fix the code and rerun until they pass. It's an autonomous, self-correcting, test-driven development loop happening right there on your machine. And it doesn't stop there. Once every single test passes, it automatically updates a preview page to render variations of your new component. And that NetNinja example, it generated an avatar and immediately displayed it with different background colors, red, blue, green, and tested 1 versus 2 initials all live in your browser. Finally, it just prints out a neat, concise summary in the CLI of exactly what it built, the branch it's on, and the modified files. Just brilliant. Okay, last part. Section 6, activating your new workflow. We've built this amazing TOML file, but there's one vital hurdle you have to remember. When you create a new custom command, the current Gemini CLI session doesn't actually know about it yet. So you just need to type /quit, hit enter, and then restart the Gemini session. That reboot is what registers your new commands. Actually, scratch that. If you forget this step, you're definitely going to be wondering why your command isn't working, so keep that in mind. The shift in how we can work is just absolutely astonishing. Just by defining a TOML file with a description, a multi-line prompt, and that dynamic args variable, we've transformed a basic chat interface into a fully automated, self-correcting development agent. It handles Git branching, writes tests, builds components, and even self-heals errors. So, I'll leave you with this. Knowing how powerful this is, what repetitive workflow are you going to automate next? Get into that .gemini folder and start building. Thanks for joining me on this explainer, and happy coding.